Hi folks, welcome back to Math with Captain Rod. I'm making this video here to provide another example here of solving equations involving logarithms. So we're going to take a look at number 14 on page 443. And here is the problem. It's kind of a messy looking thing. And the first thing I would suggest is that we try to get this into one logarithm here. I mean, there's a lot of stuff going on in that problem. So let's probably start this by grouping things together. So we're going to have log base 5 of 9x minus log base 5 of x squared minus 2 minus log base 5 of 6 equals 0. And again, I'm grouping these so I can apply that formula, you know, that like the log of a product is the sum of the logs. And you've seen my video, hopefully, where I pointed out that, you know, if you end up with an a over b, this ends up being the difference between the logs. And you can even think of it though like this log of a times b. The a over b, you can think of this as log a b to the minus 1, which would put a minus 1 here. That can come out in front. So effectively it's the same rule. So long story short, when you're using this formula, any term that's positive will end up in the numerator. These minuses, these terms will end up in the denominator. So this is going to be log base 5 of 9x, this term's positive, that's in the numerator, and that's it, minus and minus. So over this guy, x squared minus 2 times this guy, 6, and then equals 0. So from here to here, we've gotten it down to one logarithm. Now we're going to take this thing, write it in exponential form. This means 5 to the 0 equals whatever's here. 5 to the 0 is 1. So we're going to have 9x over x squared minus 2 times 6 equals 1. Next line, so 9x is going to equal, we can just multiply both sides of this equation by this. We notice it's quadratic. We love quadratics, right? 6x squared minus 12. I did that right? 6 squared. Yep, that looks good. Let's subtract the 9x from both sides. Now, again, you know, how you're going to solve it, remember, dictates what we're going to do with that constant. Right now, I'm just trying to get myself some more room here. I found myself running out of room, so I'm going to drop the side of the room. Okay. So I've set this up now for either quadratic formula or factoring. I also notice here that there's 3 is common everywhere. Why don't we divide that out? 2x squared minus 3x minus 4. This thing looks factorable. Very probably 2x and x. Let's see, factors of 4, 4 and 1, 2 and 2. Let's try the 2 and 2. And let's try 4, 2. That's not going to cut it. Let's try the 4 and 1. And let's try, let's see, 2, 4. That's probably not going to cut it either. All right. Usually for me, what I do is I usually give things to about 1,003, and if I don't get them factored, I just use the quadratic formula. I'm just going to do that. I'm sure I could get it factored, but x is going to be opposite of b, plus or minus square root of b squared. That would be negative 3 squared minus 4 times 2 times c all over twice a. So we're going to have 3 plus or minus square root of, let's see, 9. This is going to be plus, and let's see, 16 times 2, 9 plus 32 over 4. 3 plus or minus square root of 32, 42, 41 over 4. Well, maybe it wouldn't have factored.